Welcome to clickmyproject.com. Now let's see about View-Invariant action recognition based on artificial neural network. Here we propose a human action recognition system. In this paper we identify the human action by the use of NFS classifier. Human action recognition will be used in intelligent surveillance, human-computer interaction, content-based video compression and retrieval. We identify the human actions such as walk, jump, bend, etc. Initially, the actions are described as posture. After that, we extract the feature by the use of spatio-temporal feature extraction algorithm. It will derive the variation between each frames in single video. The feature values will go to the classifier to train and predict about the result. The proposed approach does not require the use of the same number of cameras in the training and recognition phases. An action captured by the arbitrary n number of cameras is described by a number of successive human body postures. The similarity of every human body posture to body posture prototypes determined by the training phase by a self-organizing neural network is used to provide a time-invariant action representation. Action recognition is performed for each of the n cameras by using a multi-layer perceptrons. Here we have to provide the input video. It should be the any type of action video such as walk, run and bend. In pre-processing, here we convert the video as frames. Frame is the one of the many still images which compose the complete moving picture. It goes to the foreground and background separation. Foreground is the human or moving object in the corresponding videos, which is separated from our input videos. It will go to the tracking process. Video tracking is the process of locating a moving object over time using a video. It is referred to mathematical methods that are aimed at detecting regions in digital image. Here we find the pixel variation between the two frames and we draw the blob to the corresponding pixels. Finally, we track the position from the video. It will go to the spatio-temporal feature extraction. Here we extract the feature of the video by the use of spatio-temporal feature extraction algorithm. First, we select the candidate points based on the surf detector. Next, we calculate the several motion features at each point with local temporal units divided in order to consider consecutiveness of motion. Finally, these feature values will go to the classification or classify the features. Here we are using the adaptive neurofussy inference system. It will train about the features and finally predict about the result. Now let's see the execution part. Here I am having main.m file. Select this file, right click and run the file. The guide window will be open. This is the guide design of our project. First we have to provide the input video. Here I am having pop-up menu. In pop-up menu totally I am having two videos. First is the bend and second one is the jump. Now I am selecting the first video. The input video will be displayed in the first axis and also it is converted as frames. In pre-processing, here we are separate the foreground and background from the video. It is a binary image. The white will denote the foreground, the black will denote the background image. In tracking process, here we are tracking the movement of human that is displayed in the third axis. Next we are extracting the feature by the use of spatio-temporal algorithm. It is a variation between the each frames. The extracted feature values will be displayed in the table values. Here totally we are having the 65 frames and 65 feature values will be extracted and it is displayed in the table. Now let's see the background frames. The background frames will be displayed in the fourth axis. Now let's see the activity recognition. Here we are using the classifier, NFS classifier. It will use to predict the result about the feature values. Now let's see the result. The action will be tracked here. After tracking, it will predict about the result. Here we are having the result as bend. Now let's see the performance. In performance, here we are evaluating the performance of classifier. This is the confusion matrix. There is no confusion or misclassification in our classifier. It will provide the 100% result. This is the performance values of our classifier. Trained and validation result are plotted in the chart. Thank you.